All right, so we use Bohr's model to explain the line spectrum of hydrogen successfully. Right. So this is one of the biggest contribution to advance the atomic theory at the time. This is 1911, I think, about 1911, 1912. Right. Sadly, however, the Bohr's model fails to explain the light spectrum of other elements. It works only for hydrogen. That's it. when an atom has got 2 electrons, like in helium, Bohr's model can explain it, right? And in 19th and 1930s, after the series of discovery, scientists start to abandon the Bohr's model. So it's just sad. Anyway, but it's the Bohr's model getting closer to the electron cloud model, the quantum model. All right. All right. Now, so this is 1912, 1911, 1912. About 15 to 16 years later, right? So Heisenberg uncertainty principles, and if you remember this guy, he said that it's impossible to know the position of the electron and its momentum at the same time. Where momentum means where it's going, right? If you know more about the position of electron, you don't know where it's going. If you know where it's going, you don't know the position, right? Just like a fan, when you know it's somewhere around here, but you can't really pinpoint where exactly the 3 blades are. All right. So, and he compromised that instead of trying to pinpoint where the electrons are exactly, why don't just give you an area that you can find the electron, and they call that an orbitals. All right. With that, we have an Austrian physicist. So his name is Erwin Schrödinger. Some of you might heard Schrödinger the cat. So the cat in the box, right? He's famous for that. That his equation. The trident that you see right here, the trident square is probability, and he uses probability to find the area that you can find an electron, probable place that you can find an electron, and you can find, and he found from his discovery, this is his calculation, is he do the math there, a lot of calculus there. He found that if you get too close to the nucleus, there's a low electron density. Further away, that's when you can find high electron density, more probability to find an electron on here. If you go further away, further out, that's a low electron density region. He plot a graph right here. So if you get too close, the electron distribution is low, so you can't really find an electron. If you go too far from the nucleus right here, you can't really find it. It's going to be somewhere like in the proper area, and the proper area, they call it orbital, which is a space around the nucleus where the probability to finding electron is high. And one orbital can accommodate 2 electrons. We'll talk about it on the next video.